Somewhere out there, the night is filled with moons. They're turning, drifting, and keeping time in silence. Each one moves through its long, patient dance, shaping tides and shadows, stirring the dreams of the planets they follow. Some glow with a soft, cold light. Others hide oceans deep beneath their skin, where the darkness hums with quiet potential. There are moons that breathe vapor into space, moons that shimmer with frost, moons that look like forgotten lanterns adrift in the void. Our own moon is only one verse in this cosmic lullaby. When you look up at it, you're seeing a reflection shared by every traveler who ever paused beneath the same sky. Out there, Titan rains methane like tears of glass. Europa sighs beneath its frozen shell. Enceladus exhales light, each one turning slowly, endlessly, as if to remind us that even in stillness, the universe keeps moving. If these drifting worlds bring a little calm to your night, you might quietly like or subscribe. It helps others find their way to this same soft place. But you don't need to do anything now. Just breathe and let the moons pull you into their orbit, where thought grows weightless and time begins to blur. The moon, faithful and familiar, is slowly slipping away from us. Each year it drifts just a little farther, barely an inch and a half, but enough to mark time on a scale too vast for human lives. The pull between Earth and its oceans transfers a quiet energy outward, urging the moon into a wider orbit. Long ago, it must have hung closer, larger in the sky, its light stronger, its tides deeper. Someday, in a future none of us will see, Earth's spin will slow and its days will lengthen, the ancient dance between planet and moon continuing in silence. What seems steady above us is always, secretly, in motion. The sky we know is only a moment in a long unfolding. Once, the moon even had an atmosphere of its own. Billions of years ago, volcanoes spread across its face, exhaling gas into space until a thin veil of air shimmered briefly around it. For tens of millions of years it lingered there, fragile but real, before drifting away. Some of that vapor may have carried traces of water, settling into the shadows of craters where it remains frozen still. The moon feels eternal when we look at it, yet its surface carries the memory of breath, a reminder that even worlds we call lifeless have stories of change and loss. Farther out, other moons circle their planets in strange and varied shapes. Not all are round or smooth. Some resemble pebbles or broken shells. Mars' small companion, Phobos, looks like a piece of rough stone tumbling through space, while Saturn's moon, Pan, seems to wear a soft ring of dust around its waist, like a pastry spun from light. These irregular bodies are too small to pull themselves into perfect spheres, and so they keep their awkward beauty. They drift like relics from the solar system's youth, fragments left over from creation's slow construction. Among them is Europa, shining white and scarred with lines like veins beneath ice. Beneath that pale crust lies a global ocean, vast, hidden, and warm enough to stay liquid. The heat comes not from sunlight, but from Jupiter's relentless gravity, which stretches Europa's interior and stirs it from within. Some scientists believe vents on its ocean floor might release minerals and warmth, just as they do in Earth's deep seas. If so, Europa could be a quiet cradle for life, sealed beneath miles of frozen glass. Its silence is deceptive. It holds the sound of potential waiting in the dark. Travel a little farther, and you'll reach Titan, Saturn's largest moon, where rain falls and rivers flow not of water, but of liquid methane and ethane. Its orange haze filters the sunlight until the world glows like amber. Lakes spread across the surface, their reflections dim but steady, sculpting shores and valleys that feel both familiar and alien. The air there is thick and heavy, a mixture of nitrogen and hydrocarbons, strange yet comforting, as if the place dreams of being Earth, but in another form. In its own slow rhythm, Titan weathers its seasons, patient beneath the cold rings of Saturn. Then there is tiny Enceladus, bright as new snow, hiding a sea beneath its ice. From its southern pole, geysers burst into the void, spraying plumes of vapor, salt, and organic material that glitter in sunlight before falling back or joining Saturn's rings. These jets are whispers from the world below, evidence of heat, motion, and perhaps the chemistry of life. When the spacecraft Cassini once flew through them, it caught the taste of that ocean on its instruments, a trace of salt, of energy, of something alive in possibility. Enceladus, though small, carries the shimmer of mystery wherever it goes. Closer to Jupiter, the moon Io burns like an ember. Volcanoes there never rest. They send fountains of molten rock, rising miles high, painting the surface anew again and again. The immense pull of Jupiter and its sibling moons stirs Io's insides until the crust itself trembles and glows. To stand there would be impossible, the air too thin, the heat too fierce. But from a distance, Io shines like a world of fire, caught in perpetual renewal. Ganymede, the giant among moons, is another kind of wonder, larger than Mercury. It hums with its own magnetic field, a sign of molten metal moving deep inside. Its frozen surface bears scars of time craters, grooves, and plains shaped by ancient shifts. Around it, a faint atmosphere of oxygen drifts, fragile but steady. Were it orbiting the Sun instead of Jupiter, we might have called it a planet. Yet it remains a moon, vast and self-contained, holding its secrets quietly. And through it all, our own moon continues to watch over Earth, keeping our planet balanced in its slow spin. Its gravity steadies the tilt of our axis, softens the wild swings of climate, and gives rhythm to the seas. Without it, Earth might lurch unpredictably through space, its seasons chaotic, its life uncertain. The moon's calm presence has made our world habitable, its silver pull a silent guardian across time. When you look up tonight, remember that every moon, fiery, icy, tiny, or immense, plays its part in the great, slow choreography of the cosmos. Each one moves to an ancient rhythm, steady and patient, as the universe itself drifts quietly onward. The moon's pull does more than light our nights. It shapes the rhythm of the world below. Every tide that rises along a distant shore is part of a slow, ancient exchange between Earth and its satellite. A quiet heartbeat passed through water. Those shifting tides may once have stirred the chemistry of life itself, mixing elements in shallow seas, nudging the first fragile molecules towards something that could grow, adapt, and dream. In that way, the moon became not just a companion in the sky, but a silent architect of our beginnings, a guardian whose gravity steadied Earth's spin and softened the chaos of its early storms. To look up at it now, glowing faintly through the thin breath of night, is to glimpse a story written in both ocean waves and human hearts. Yet the moon's serenity hides a fierce birth. Long before it became the silver constant we know, the young Earth was struck by a wandering world, nearly its own size, a planet we now call Theia. The collision was unimaginable. Two worlds colliding in molten fury, their surfaces flung into space. From that cloud of debris and fire, a new body slowly took form, Dust became stone, stone became a sphere, and the moon emerged, glowing red with heat before it cooled into calmness. Its rocks still carry the chemistry of Earth's own crust, twin signatures of that cosmic upheaval. Out of destruction came stability, and from chaos, rhythm. The moon's orbit, once chaotic, gradually settled into balance, its rotation locking, so that one side forever faces us, a face that has watched every age of life unfold below. But even this familiar face tells only half the story. The other side of the moon, turned away for billions of years, is a different world altogether. The near side, the one we see, is marked by wide, dark plains of frozen lava called Maria, born from ancient volcanic seas that spread like ink across the surface. The far side, hidden from view, is rough and mountainous, pocked with craters and bathed in eternal shadow. For most of human history, that unseen half was the stuff of dreams and myths. Then, in the mid-20th century, spacecraft turned their cameras toward it and revealed a surprise: a second moon, wild and rugged, orbiting invisibly beside the one we thought we knew. Scientists think the difference between the two faces began long ago, when the moon's crust cooled unevenly, one side warming faster, its basins filled by magma, the other left pale and untouched. What we see each night is only half of what is real, the rest still turning quietly away. Beyond our moon's soft light, the solar system holds stranger companions. Around Neptune drifts Triton, an icy traveler caught moving in the wrong direction. Unlike most moons, which follow their planet's spin, Triton loops backward, a captured wanderer that likely began life as a dwarf planet in the Kuiper Belt. Its surface gleams faintly pink from frozen nitrogen and methane, and faint geysers of gas rise through its thin atmosphere like ghostly breaths. That backward motion carries a price. Neptune's gravity is slowly dragging Triton inward. One distant day, it will cross the invisible threshold called the Roche limit, and the strain will tear it apart. When that happens, Neptune may wear Triton's remains as a ring, a bright memorial of a moon that lost its balance in orbit. But Triton's fate is not unique. Moons everywhere walk a delicate line between creation and dissolution. When they drift too close to their planets, tidal forces stretch them thin. Some survive, their crusts scarred but whole. Others crumble, scattering into dust that becomes rings. Over time, those rings may gather again into new moons, completing a cycle of endless rearrangement. Astronomers see this in the story of Mars's small moon Phobos, which creeps a little closer to the planet with every orbit about 7 feet each century. In 50 million years or so, it will either shatter into a halo of rubble or fall to the surface as a final offering to the world that held it. The grooves that score its skin may already be the cracks of that slow unmaking. Every moon, even the smallest, carries the quiet reminder that permanence is an illusion. Orbits, like tides, only seem eternal when seen from far away. In the outer darkness, beyond the orbit of Neptune, Pluto and its companion Charon move in a more graceful balance. Charon is so large, half the size of Pluto, that the two bodies orbit a shared point in space, a gravitational dance rather than a hierarchy. If you could watch them from afar, you would not see a planet with a moon, but two companions turning face to face, locked in an equal waltz through the cold. Their shared center lies outside Pluto itself, so neither leads nor follows. In the dim sunlight of that distant frontier, the two appear almost still, circling each other like partners in a dance that never ends. Not all moons are so serene. Around Uranus, tilted and pale, spins Miranda, a fractured world that looks as if it has been broken and rebuilt. Its surface is a patchwork of ridges and plains that seems stitched together by time. Some cliffs rise 12 miles high, the tallest in the solar system. A stone dropped from their edge would fall for 10 long minutes before touching ground. Scientists believe Miranda once shattered entirely, perhaps from a colossal impact, and then slowly drew itself back together under its own gravity. The scars of that reconstruction remain: vast canyons, mismatched textures, ancient layers like torn fabric. Miranda feels like a survivor of something immense, a moon that refused to stay broken. Elsewhere, other moons bear quieter wounds. Rhea, another of Saturn's many satellites, is pale and cracked, its surface etched with ghostly streaks that may be the trails of long-vanished rings. Iapetus, half dark and half bright, spins like a coin caught between shadow and sunlight. And in the outer reaches, faint and far, Nereid moves in an orbit so stretched that it swings from near to far like a pendulum frozen in slow motion. Each of them holds a fragment of history, a different rhythm in the symphony of gravity and time. Closer to home, Mars's moon Phobos continues its inevitable descent, pulled ever downward by the planet's gravity. Its smaller sibling, Deimos, drifts farther out instead, slipping slowly toward escape. One falls, the other flees, the simplest and oldest story in the heavens. If you could stand on Mars and watch Phobos rise, you'd see it racing across the sky 3 times a day, each pass a little faster than the last. Eventually it will crumble, its fragments spreading into a faint, temporary ring before fading to dust. Mars will carry that ring for a while, then lose it, just as all worlds lose their companions in time. Every moon, no matter how small or distant, tells a part of the same tale. They shape and are shaped, born in collisions, sculpted by tides, undone by gravity, reborn as light. Some guard their planets like sentinels. Others wander freely, captured and recaptured in endless orbits. Together they remind us that the universe is not still, but breathing. It stretches and contracts, builds and releases, just as we do when we sleep beneath its quiet glow. When you look up at the night sky, the moon's pale reflection is only the nearest verse of a larger song, a song of drifting worlds, of balance and change, of motion so slow it feels like peace. The moon still stirs, even in its silence. Beneath that calm, pale surface, it sometimes trembles faint, patient quivers that ripple through stone. Long ago, Apollo astronauts left small seismometers on the lunar plains, and from those instruments came the discovery: the moon has its own heartbeat. Some of these tremors are gentle echoes from Earth's pull, the slow tightening and loosening of invisible tides. Others happen when the frozen crust warms in sunlight, cracking softly as if exhaling. And deeper still are quakes with no clear cause, vibrations that rise from within, their origins still unknown. Because the moon's crust is dry and rigid, these shivers can last for hours, the sound of energy finding no place to fade. What seems lifeless from afar still carries the quiet pulse of movement, the trace of something enduring deep inside. If you could scoop a handful of lunar soil, you would find it glinting with tiny beads of glass. Each one was born from fire droplets flung into the sky by volcanic eruptions billions of years ago, cooled and frozen in flight. For ages, they seemed nothing more than bright dust, but hidden within them, scientists have found traces of water, locked away in microscopic prisons of glass. Though the moon appears bone dry, these beads may hold vast stores of moisture, tiny reservoirs born of flame. Someday, explorers may draw that hidden water to drink, or to launch new journeys farther into the dark. Inside each bead lies the memory of the moon's volcanic youth and the quiet promise that even in barrenness, something vital remains. For those who walked upon its surface, the moon offered another surprise, a scent. When the Apollo astronauts returned to their landers and removed their helmets, the gray dust that clung to their suits filled the cabin with an unexpected smell, sharp and dry, like metal singed by heat. That dust, the lunar regolith, is made of countless shards of glass and stone ground to powder by billions of years of impacts. Underfoot, it is soft and fine, but its edges are jagged enough to tear fabric and scratch skin. It coated everything, clinging like smoke, whispering that this was a world untouched by air or rain. To breathe near it was impossible. To smell it was unforgettable. The scent of a world that has no life, but still leaves a mark. Long after those footprints faded, the instruments the astronauts left behind continued their quiet work. Among them were small mirrors, retroreflectors that still catch beams of light from Earth. Scientists send lasers up through the atmosphere, watch them strike those mirrors, and measure how long the light takes to return. The data show that the moon is drifting slowly away, inch by inch, but those pulses of light are proof that the connection endures. In the darkness above, the mirrors gleam faintly, linking two worlds with threads of brightness thinner than thought. Other instruments listened for temperature shifts and subtle vibrations, recording the stories of a world that never stops changing, even when no one is there to see it. The moon, though distant, still carries the touch of human hands, a reminder that curiosity can travel farther than any footprint. Far from Earth, beyond the orbit of Jupiter, another ancient moon keeps its own secrets. Callisto, scarred and gray, wears its history openly. Its surface is older than nearly any other in the solar system. Every crater a memory of impact and endurance. At first glance, it seems frozen and inert, a fossil of ice and stone. But deep beneath that battered shell may lie a hidden ocean, salty, ancient, and preserved for billions of years. If true, it would mean that even in the quietest corners of the outer solar system, water has not forgotten how to survive. Callisto does not erupt or tremble like its restless siblings, Europa or Io. It simply endures. Its silence is not emptiness, but patience, the kind that holds entire oceans beneath layers of time. Not far from there, Saturn's moon Iapetus turns slowly in its orbit, half glowing, half dark. From one side, it gleams like snow under sunlight. From the other, it is black as soot. For centuries, astronomers wondered why one hemisphere drank in light while the other reflected it away. The answer seems to lie in dust, fine particles from another moon, Phoebe, drifting across space to settle on Iapetus's surface. Once there, sunlight warmed the darkened regions, deepening their color until half the world became a mirror of contrast. Seen from afar, Iapetus looks like a symbol, a cosmic yin and yang gliding through Saturn's rings, bright and shadowed, whole in its division. A ridge runs along its equator, making it oddly shaped, like a walnut, spinning through light and darkness. No other moon wears its duality so plainly. And then there is Hyperion, one of Saturn's strangest companions, a small, tumbling world that never seems to turn the same way twice. Pitted with deep craters, Its porous surface gives it the look of a sponge adrift in space. It spins chaotically, sometimes wobbling, sometimes tumbling end over end, as though it can't decide which direction belongs to it. Unlike the great, steady moons, Hyperion's rhythm is unpredictable, a dance that defies pattern, guided only by chance and gravity. Scientists believe its low density and odd shape make it fragile, a heap of icy rubble barely held together by its own pull. Yet, in that fragility lies a strange grace. Hyperion drifts through Saturn's orbit like a dream that cannot settle, spinning softly in the vast quiet. Its every turn, a whisper of cosmic uncertainty. In all these worlds, from our trembling moon to the distant, tumbling moons of Saturn, the same truth lingers. Silence is never stillness. The universe hums, even in its quietest places. Beneath layers of ice, inside tiny glass beads, within dust that smells of forgotten fire, motion continues. Each moon keeps its own rhythm, slow, ancient, and unhurried, and together they form a symphony of subtle movement, so delicate it feels like sleep. Some moons glow where darkness should have no color, bathed in invisible rivers of magnetism. They wear crowns of light auroras drifting across their frozen skies. Ganymede, vast and self-contained, carries its own magnetic field, so its poles shimmer with shifting veils of blue and green, unseen by human eyes, but captured by instruments that listen to light. Even moons without such power can borrow it. Charged particles from their planets sweep across their surfaces, sketching brief strokes of radiance across ice and rock. Imagine that, a silent world without air, alive with a storm of light that no one can hear. Space, though empty, is never still. It hums, it paints, it breathes. Far from the sun, warmth still finds a way. Moons that should be frozen solid often hide their heat within, warmed not by sunlight, but by gravity's patient hands. As they orbit, their planets stretch and squeeze them ever so slightly, and that flexing becomes friction. That friction becomes heat. Deep below, the ice melts into secret oceans. Europa glows with that hidden life, its crust scarred with long blue cracks where the ice shifts above a restless sea. Enceladus, though smaller, erupts its own proof, plumes of water and salt bursting from its southern pole, fountains that sparkle in sunlight before falling back as snow. Even Callisto and Titan may hold deep, ancient waters beneath their crusts, sealed off for billions of years, yet somehow still warm. To know this is to realize that the solar system's most promising havens for life may lie not on planets, but beneath miles of silent ice, where gravity itself keeps the flame alive. Some moons, though tiny, carry skies thick enough to change color. Titan's air presses close and heavy, denser than our own, a blanket of nitrogen laced with a haze of orange light. The sunlight there is dim, but it glows softly through layers of cloud and mist. Methane rains fall from the sky in silvery threads, carving rivers into the frozen ground and feeding lakes that mirror the dim horizon. Winds sweep across dunes of dark sand. If you could stand there, you would feel the air around you heavier than Earth's, yet calm, as if the whole world were exhaling in slow motion. Titan's skies may resemble what Earth's once were, when life was still learning to breathe. It is a reminder that moons are not only companions, they can be miniature worlds, each with its own weather, history, and dream of life. Drifting closer to Saturn's shimmering rings, a tiny moon called Pan carves a narrow path through the dust. It is barely 20 miles wide, yet perfectly shaped, like a flying saucer or a handmade trinket left to spin among the stars. Along its equator, a thin ridge of collected ice and dust gives it its strange shape, a rim formed from the very ring it helps divide. Seen from afar, it looks playful, almost unreal, as though sculpted by curiosity itself. But even such a small world can leave a mark. Pan's orbit shapes the structure of Saturn's rings, its gravity guiding grains of ice into gentle order. In its wake, it proves that even the smallest moons can write patterns into space. Another moon nearby, Mimas, wears a single enormous crater on its face. A wound so large it gives the world a strange resemblance to the Death Star from old films. But there is nothing menacing here. Mimas is small and fragile, made of ice rather than steel. The crater's walls rise like frozen waves, the floor shadowed and deep. For decades it seemed a quiet, battered world. But new studies hint at something unexpected warmth beneath the surface. Perhaps even a hidden ocean. What once looked like a symbol of lifelessness may conceal movement, liquid, and possibility. Even the most familiar faces can keep their secrets. Around Jupiter, a red-tinged moon called Amalthea turns through faint rings of dust. It is no larger than a mountain chain, yet its peaks and valleys rise higher than Earth's Everest. Its faint glow may come from sulfur, cast off by nearby Io, painting its surface with volcanic blush. Amalthea's rugged body sheds fine particles that drift outward, feeding Jupiter's gossamer rings. Though small, it sculpts beauty on a grand scale, a reminder that in the cosmos, greatness is not measured in size but in presence. Farther out still drifts Himalaya, another of Jupiter's wanderers. Unlike the larger moons, it does not move neatly along Jupiter's equatorial plane. Instead, it circles at a tilt, far beyond the others, following a lopsided path through the dark. Scientists believe Himalaya was once an asteroid, pulled from the cold outer belt and trapped by Jupiter's immense gravity. Its surface is dull gray, its shape uneven, but its story is compelling. A traveler caught mid-flight, claimed by a giant, and never let go. Many of the small moons that orbit distant worlds share this origin. They are wanderers, made into kin reminders that in space, capture and companionship often mean the same thing. Not all moons obey the flow of their planets. Some turn the opposite way, retracing the dance in reverse. These are the retrograde moons, rebels among the countless orderly orbits. Triton is the grandest of them, circling Neptune backward, its frozen plains veiled in faint, drifting gas. Many others are smaller, captured fragments that defy the direction of time itself. Their backwards motion tells a story of collisions and chance, of wandering bodies drawn in by gravity's unpredictable embrace. The universe is full of such meetings, violent, elegant, accidental, that remake systems and redefine their harmony. Even disobedience becomes part of the pattern. And then there are two moons that refuse even to choose who leads. Janus and Epimetheus, twin companions of Saturn, share nearly the same orbit. They dance side by side, sometimes one inside, sometimes the other. Every few years, they approach each other, and when they meet, their gravity trades places. The inner moon drifts outward, and the outer one slips inward, a flawless exchange that never collides. It is a choreography of balance, performed endlessly against the pale glow of Saturn's rings. They prove that even in the vast machinery of orbits, there can be gentleness, grace, and trust. Across these far-flung worlds, light, motion, and gravity weave the same melody. Some moons shimmer with auroras, others whisper with tides beneath their ice. Some rebel, some endure. Some trade orbits like dancers exchanging steps. Together they form a kind of cosmic harmony, a lesson written in silence, that even the smallest bodies, spinning in the dark, can hold beauty, rhythm, and a touch of wonder that keeps the universe awake. The moons of the solar system turn at different tempos, each keeping its own secret rhythm. Some move so slowly that their spin could be mistaken for stillness. Many are tidally locked, always facing the planet they orbit, bound by gravity's steady insistence. The same side, held forward forever. To us, they appear frozen, but in truth they turn just once with each circuit, their rotation hiding inside the grace of their orbit. Others move even more sluggishly, their spins slowed by irregular shapes and tugging tides, until days stretch into weeks, and a single rotation takes the patience of seasons. If you stood upon such a world, the sky would be an exercise in stillness. Stars would creep across the heavens so slowly that you might go to sleep and wake again before a single constellation had shifted. Shadows would crawl like ice across rock. A day would lose its meaning entirely. Time itself would seem thick, softened, as if the entire universe were breathing slower. On these moons, you could almost believe that eternity has a heartbeat faint but steady. Our moon, though far livelier, moves to a similar rhythm of quiet control. Its gravity reaches across 250,000 miles to steady our planet's tilt. Earth leans at 23.5 degrees, and that lean gives us seasons, the alternation of warmth and rest that defines our calendars and our lives. But left alone, that tilt would wobble wildly, swinging between poles of ice and waves of heat. Mars, with no great moon to calm it, endures such chaos. Its axis shifts over eons. Its climates rise and collapse. Its deserts remember vanished glaciers. Earth is spared this instability because of the moon's patient hold. Its constant tug steadies the spin, damping the planetary sway, and with it, the drama of extinction and rebirth. Every stable forest, every coral reef, every migrating flock owes a small debt to that distant companion. It acts as an anchor in space, invisible in daylight but always working a balance keeper, ensuring that change on Earth comes slowly enough for life to adapt. Our ancestors could not see its influence, yet they felt it in the predictability of the seasons, the regular return of spring, the soft symmetry of dusk and dawn. The moon's pull is not loud, not visible, but written into the rhythm of existence itself. Even the length of our days is its handiwork. In the beginning, Earth spun fast, a single day lasting just 6 hours. The oceans rushed and shifted under the moon's pull, transferring energy from rotation to orbit, from planet to satellite. Each tide that rises and falls is a small act of exchange, Earth's spin giving a fraction of its energy to push the moon a little farther away. Over billions of years, that trade has lengthened our days by roughly 2 milliseconds each century. A whisper, a subtle drag, but an inexorable one. The day you live now, the breath you count, is longer than it would have been in the age of the first single-celled life. The moon stretches time itself, teaching patience to a restless world. Yet the face we know so well, pale, cratered, marked with shadows, once burned with light. Long ago, the young moon was violent and molten. Gigantic impacts cracked its surface, and molten rock welled up through the fractures. Rivers of glowing lava spread outward, filling low basins with shimmering fire. Seen from Earth, the moon must have blazed like an ember, radiant with heat, its entire face glowing orange against a newborn night. Slowly, that heat cooled and hardened into basalt plains. Those dark patches that shape the familiar man in the moon are the frozen remnants of those seas called Maria, the Latin word for oceans. They are the moon's memory of its fiery youth, burned into permanence. When early observers looked upward, they imagined oceans and continents, shapes that seemed alive. They weren't wrong to see movement there. It was simply motion slowed by time, the quiet aftermath of a world remade. Even now, remnants of that ancient fire linger in unexpected forms. Scattered through the moon's soil are microscopic beads of glass droplets once flung from volcanic fountains billions of years ago, cooled as they fell. Inside those glass spheres, scientists have found traces of water trapped in the heat of creation. Each tiny bead is a vessel holding both fire and ice, born in eruption, now a reservoir of quiet moisture. Though invisible to the eye, these beads could one day sustain explorers a source of water, air, and fuel for journeys yet to come. What once erupted as destruction may someday become a well of life, and where light fades completely, in the craters near the poles where the sun has never risen, there is another miracle. Within those eternal shadows lies ice that has never melted ancient frost, delivered by comets, preserved for billions of years in cold so deep it silences all motion. These frozen reserves sleep, untouched and unseen, but they hold the promise of renewal. For those who may one day walk there again, they offer a drink, a breath, a way forward. The moon, long thought barren, is instead a quiet keeper of resources, a world still waiting to give. Yet for all it holds, the moon reflects so little of what it receives. Its brightness is an illusion of contrast. The lunar soil, dark basalt and dust, reflects only about 12% of the sunlight that strikes it. By comparison, worn asphalt is brighter. If you could place the moon beside Earth in open space, our planet would dazzle blue and white, and the moon would seem dull gray by its side. But in the black of night, that faint reflection becomes radiant, enough to illuminate oceans and forests, snowfields and skin. Its light is borrowed but transformed, made soft by distance and shadow. It reminds us that even dim things can glow when surrounded by darkness. The moon's beauty, though, hides a roughness that few can imagine. Its soil is a landscape of knives. Billions of years of meteor impacts have ground rock into fine, glassy dust, each grain edged with sharp corners. With no wind or rain to wear it smooth, it stays cruelly abrasive. When the Apollo astronauts walked there, the dust clung to their boots and gloves, tore at seals, scratched their visors, and filled their air with a metallic scent, like burnt stone. It even cut through fabric, leaving fine tears in the suits that protected them. The dust is the record of time's violence, every collision, every impact, every unending fall written into a powder that remembers everything. To step on the moon is to walk across the ashes of creation itself. Yet the connection between Earth and moon runs deeper than dust or light. The moon's gravity tugs not only at the oceans, but at the very shape of the Earth. Our planet is not perfectly round. It stretches slightly toward its companion, forming a faint bulge in stone and sea alike. That subtle distortion moves as the moon moves, following it across the sky. We cannot feel it, yet it happens beneath our feet every day. The two bodies lean toward each other across space, bound by invisible threads. Their dance is ancient, a partnership of motion and response, giving and taking, always adjusting, always balanced. Earth pulls the moon forward, the moon steadies the earth, and together they create a harmony that keeps the system alive. But even harmony has limits. When a moon wanders too close to its planet, gravity turns from a guide to a destroyer. The side nearer the planet feels a stronger pull than the far side, and the difference stretches the moon until it breaks. This boundary, known as the Roche limit, marks the threshold between unity and disintegration. Cross it, and stone becomes dust, orbit becomes ring. Astronomers believe Saturn's bright rings may have begun this way from a moon drawn too near, torn apart, and scattered into light. Mars's moon Phobos is moving slowly toward that fate, creeping inward with each orbit. One day, it too will cross the invisible line and unravel into a halo of rubble circling the red world. Even destruction here is beautiful, a reminder that form is temporary, but motion endures. Everything in this cosmic relationship, spin, tide, time, and dust, reveals the same truth. What seems permanent is always shifting. What seems solid is shaped by unseen hands. The moon is not merely a mirror, nor just a relic of the past. It is a participant, a partner in Earth's story, guiding the length of our days, the balance of our tilt, the pace of our tides. It shapes the air we breathe and the waters that cradle life. Every beam of moonlight carries the history of lava, ice, dust, and pull. Every quiet night is a collaboration between two worlds locked in gravity's slow embrace. If you listen closely in the hush between waves, in the rhythm of your own breath, you can almost hear it. That slow exchange of motion, the whisper of rock against tide, the sound of time stretching under the weight of patience. The moon turns, the earth bends, and together they compose a lullaby for a restless planet, a song so soft it has lasted billions of years. Some moons live their whole lives in perfect rhythm, turning always in step with their planet. Our own moon is one of them, a dancer caught in the same slow spin, rotating once on its axis for every journey it makes around Earth. Because of that, we always see the same familiar face, while the far side remains hidden, forever turned away. This balance did not happen all at once. It was gravity, patient and persuasive, that slowed the moon's rotation until motion and orbit became one. It is a kind of eternal duet, two partners circling endlessly, each shaping the other's steps. Such harmony feels inevitable, yet it is born from struggle, friction, pull, resistance, surrender. Across the solar system, many moons live in this same trance of balance, proof that even chaos, given time, can settle into grace. But not all orbits are so still. Some moons share paths so close that they weave around one another, swapping places in a dance as intricate as any waltz ever written. Around Saturn, two tiny worlds, Janus and Epimetheus, glide side by side along nearly the same track. Every few years, one creeps ahead of the other. When they draw near, gravity stirs between them like breath, and instead of colliding, they exchange orbits. The outer one drifts inward, the inner one slides out, and both continue circling the planet as if nothing happened. This has gone on for millions of years, a choreography carved into the very laws of motion. Watching them from afar would be like seeing two lanterns in space swap their glow, a gesture of perfect trust, written in the language of gravity. That pull, the quiet persuasion of one body on another, doesn't end with distant worlds. Even here, on Earth, we feel the moon's touch in ways both gentle and deep. It tugs at the oceans, raising tides that roll across continents, but it also reaches through water and into stone. Scientists call them tidal stresses, tiny pulses of force that flex Earth's crust. Alone, they are harmless, but in the right place, at the right moment, they can push a restless fault or stir magma waiting beneath. They don't cause earthquakes or eruptions, but sometimes, like a whisper that breaks a tense silence, they nudge an already trembling world into motion. That the moon, so far away, could stir the ground beneath our feet is a reminder of how connected everything is, that the same rhythm moving the tides can echo faintly through mountains and fire. Beyond our own world, moons grow stranger and more complex than imagination first allows. Take Ganymede, the largest moon in the solar system, larger even than Mercury. Beneath its pale crust lies a vast sequence of layers: ice, then water, then more ice, then more water stacked like a cosmic sandwich, miles deep. Pressure inside is immense, enough to turn ice into unfamiliar forms, dense and exotic. At its core, molten metal swirls, creating a magnetic field of its own, something no other moon can claim. If we could peer into its depths, we'd see an architecture of water and stone, shaped by pressure and time, a frozen cathedral built by gravity's slow art. Then there is Io, Ganymede's fiery sibling. While one world sleeps under ice, the other never stops burning. Io is the most volcanic body in the solar system. Its surface, a canvas of molten color, forever erased and rewritten by eruptions. Rivers of lava can stretch for hundreds of miles, glowing orange and red as they flow, reshaping mountains, filling craters, remaking the land. Giant plumes of sulfur rise hundreds of miles into space, painting Jupiter's magnetic field in hues of yellow and gold. No map of Io stays true for long. The whole world is in motion, trembling under Jupiter's pull. Each eruption is both destruction and renewal. The same forces that tear the moon apart also keep it alive. Farther out drifts Europa, as pale as bone and just as smooth. Its face is etched with long scars, cracks, and ridges running across the ice like veins. Where most moons are cratered and ancient, Europa's surface looks young, constantly refreshed. That's because it floats above a hidden ocean, kept liquid by the same gravitational flexing that feeds Io's fires. The ice above creaks and shifts, breaking and freezing again, erasing old scars. Some fractures ooze reddish stains, salts, and organics drawn up from the depths. If we could listen closely, we might hear the ice sighing as it moves, the sound of a frozen sea breathing underneath. It is one of the most promising places to search for life beyond Earth, a world that wears stillness as a disguise for motion. And then, on the edge of Jupiter's domain, lies Callisto, the quiet one, the ancient moon that time forgot. Its face is mottled with countless craters, some so old they predate nearly everything else still standing in the solar system. 4 billion years of history lie there, untouched, each crater a frozen echo of some long-vanished impact. Callisto has no volcanic heat, no ice flows, no shifting crust, only stillness. It is a museum of stone, a library of collisions preserved in silence. To look at Callisto is to peer backward into the dawn of the planets, to see the marks of an age when worlds were still finding their shapes, where Io is chaos and Europa is restlessness. Callisto is memory, a body that has chosen to remain still, carrying the record of time itself. Move outward to Saturn, and the story turns toward strangeness again. Titan, its largest moon, hides beneath a dense orange haze. Through that haze lie mountains taller than the Rockies, but made not of rock, rather of frozen water, as hard as granite in Titan's deep cold. Lakes and rivers of liquid methane cut through the valleys, glinting faintly under a dim amber sky. Winds sculpt dunes of dark organic sand, and rain falls in slow drops that evaporate before they hit the ground. It is an alien Earth, familiar in shape, utterly foreign in substance. Standing there, you would see mountains of ice and seas of hydrocarbons under a sky thick with golden clouds. Titan reminds us that the universe does not repeat itself. It rhymes, changing the words each time. And then there is Enceladus, small enough to fit between cities, yet alive with movement. Near its south pole, the ice cracks open, and geysers of water shoot into space fountains of salt, vapor, and dust that rise hundreds of miles high. These plumes come from an ocean buried beneath its crust, an ocean connected to the vast machinery of Saturn's rings. Every spray adds new particles to the E-ring, feeding a halo that circles the planet in glittering mist. What seems fragile, a moon only 300 miles wide, has reshaped one of the grandest sights in the solar system. Enceladus is proof that size means little. Even the smallest worlds can speak with astonishing grace. Farther still, in Neptune's realm, another world carries its own quiet story. Triton, cold, bright, and backward spinning, is sheathed in nitrogen ice. At those frigid temperatures, nitrogen flows like wax, sliding and reforming, smoothing the surface until it shines. Voyager 2 saw geysers of gas venting into the thin air, trailing dark plumes across the plains. They prove that even here, where sunlight is weak and seasons last a century, motion persists. Beneath its surface, Triton may still be alive, warmed by tides and pressure, reshaping itself at a pace too slow for eyes to see. It is the ghost of a planet that once roamed free, a wanderer captured and tamed by Neptune's gravity, still dreaming of its old path through the dark. Some moons bear their violence openly. Charon, the largest moon of Pluto, carries a scar across its surface so immense that it dwarfs the Grand Canyon fourfold. This chasm, over 1,000 miles long, may have formed when Charon's interior froze and expanded, cracking its crust open like glass under strain. Imagine standing at its edge, a horizon split in two, cliffs plunging miles into shadow, an emptiness so deep the far wall disappears into the haze of your own breath. On so small a world, the scale feels impossible, as though gravity forgot how to limit itself. Even the smallest places can hold the grandest wounds. Still smaller, around Uranus, spins Miranda, a moon that looks as though it was shattered and pieced together again by uncertain hands. Its surface is a mosaic of mismatched terrains, valleys that end abruptly, ridges that cut through plains of chaos, and Verona Rupes, a cliff 12 miles high, the tallest known anywhere in the solar system. A fall from its rim would take 10 minutes to reach the bottom. Scientists think Miranda once broke apart entirely, then reassembled under its own gravity, carrying the fractures of that trauma ever since. It is a survivor, its very shape proof that even what's broken can hold together again. Not all moons are born where they belong. Neptune's family, unlike Jupiter's or Saturn's, seems to have been gathered from elsewhere, captured fragments of the outer solar system, drawn in by its pull. Many of its moons travel on tilted or retrograde paths, their orbits like scattered memories of violent meetings long ago. Triton itself may once have been a dwarf planet, free and wandering, before Neptune's gravity caught it. The capture must have been cataclysmic. Earlier moons likely torn apart or ejected, new orbits carved from wreckage. Today, Neptune's moons circle quietly, but their tilted paths and backward spins tell the truth. They are a family built from strangers, fossils of migration and accident, survivors of a time when chaos was still the rule. Mars, too, keeps its small companions close, though one is destined to leave, and the other to fall. Phobos, the larger, is a misshapen world only 14 miles across, its surface scarred with long grooves and cracks that run like veins. For years, scientists wondered what caused them. Impacts? Rolling boulders? The leading belief now is simpler and sadder. Those fractures are the first signs that Phobos is coming apart. Mars's gravity is tugging at it relentlessly, drawing it inward a few centimeters each year. In tens of millions of years, the little moon will likely break apart, forming a ring of dust around Mars, a temporary crown before fading into nothing. Phobos already wears its future on its face. Its sibling, Deimos, follows a different fate. It orbits high above, smooth and steady, too far to be dragged down. Seen from the Martian surface, it moves so slowly that it might take 3 days to rise and set, drifting like a faint star that refuses to fall. While Phobos races toward destruction, Deimos lingers in peace, circling at a distance where time seems to lose urgency. If you stood on Mars and watched them both, you'd see two versions of eternity. One rushing to end, one content to wait. Each of these worlds, from the molten heart of Io to the whispering frost of Triton, is part of the same vast pattern, gravity's endless experiment in rhythm and balance. Some are bound so tightly they can never turn away. Others trade places without collision. Some tear themselves apart, while others rebuild from ruin. Each carries its own expression of motion, spinning, trembling, glowing, sighing. Together, they form a silent symphony of orbits and tides, of heat and ice, of creation and collapse. If you could hear the universe hum, you might recognize their music. The low note of Io's magma, the slow chord of Europa's creaking ice, the faint trill of Enceladus's geysers, the heartbeat of Earth's tides beneath the moon. All of them keep time in the same way, not by hours, but by patience. What looks frozen is still moving. What seems still is simply turning too slowly to see. And in this quiet dance of worlds, this unending pulse of gravity and grace, lies a truth as gentle as sleep itself. Nothing in the cosmos is truly at rest. Even silence has emotion. Even the dark glows faintly when touched by another's light. The moons remind us of that to move together, to hold balance, to shine softly in borrowed light, is its own kind of life. Not every moon glows. Some live at the edge of darkness, as if the night had gathered itself into a body and set it adrift. Their surfaces are matte and coal-dark, swallowing sunlight instead of sending it back. Around Jupiter and Saturn, many of these shadowed companions keep low profiles. Himalaya among Jupiter's irregulars, and numerous small outer moons around Saturn worlds likely captured from far colder neighborhoods and stained with carbon-rich material. Their shapes are uneven, their orbits tilted or stretched, their presence more whisper than announcement. Even standing close, you'd notice how reluctantly they shine. They feel older than the planets they circle, as though they remember a time before order, before the great disks of gas and dust settled into families. In their hush, you can sense the outer solar system's slow heartbeat. Elsewhere, the story reverses in a flash of white. Enceladus drifts like a flake of fresh snow against the black, its surface renewed so often by geysers that it reflects nearly every ray that touches it. The ice falls back like frost from its own sky, polishing the crust until it gleams a pearl in the cold. That high reflectivity is more than a pretty statistic. It's a sign of motion, of a world that refuses to sit still. A dark moon keeps its scars. A bright one continually restores itself. Brightness becomes biography. You are looking at a surface young enough to have shed its soot and stories, and written new ones in clean ice. Between these extremes, the giants keep their retinues, and some of those retinues arrive in flocks. Around Jupiter and Saturn, dozens of small, irregular moons orbit together in loose families, miniature systems inside larger ones. They share similar tilts or elongated paths, as if they were once a single body shattered by an ancient impact. The pieces never left home. Gravity swept them into a collective, the way a river gathers driftwood into an eddy. Each fragment keeps some trace of the original, the same darkness, the same kind of orbit, and together they tell a story. Fragments tell so well that even destruction can settle into a kind of order if you watch long enough. For a long time, we didn't know to watch. Then, in the winter of 1610, a man with a small tube of lenses pointed it at Jupiter and noticed 4 tiny lights keeping it company. Night after night, those lights shifted positions, weaving around the planet like slow insects around a lantern. Galileo understood what he was seeing: worlds orbiting a world. That single realization moved the center of the universe out from under our feet and set it loose among the planets. The Galilean moons, Io, Europa, Ganymede, and Callisto, became the first places beyond Earth that we could recognize as places, not just points. They continue to be teachers. Stand with one eye in that old Florentine night and the other in a modern observatory, and you feel a continuity. The sky is not a ceiling, but a map, and the map has depth. Listen long enough, and you begin to hear rhythm. Among those 4, 3 keep time so cleanly it might as well be music. Io, Europa, and Ganymede are locked in a 1, 2, 4 resonance. Every time Ganymede completes a single orbit, Europa goes twice, and Io closest and fasted circles 4 times. Gravity carved that arrangement the way water carves a channel, shaving away anything unstable until only pattern remained. Resonance does more than synchronize their motion. It kneads their interiors. As they move through one another's pulls and Jupiter's great tide, their insides flex and warm. On Io, that warmth erupts as rivers of lava that can burn across hundreds of miles. On Europa, it sustains a global ocean beneath a hard, bright shell of ice. The metronome keeps ticking, and the energy keeps moving, turning rhythm into geology. Farther out, the orchestra swaps instruments. At Saturn, tiny shepherd moons glide along the planet's rings, tugging at the ice grains as if smoothing a scarf. Pan pries a sharp gap in the A-ring. Prometheus and Pandora herd particles into the slender filament of the F-ring. Their gravity is modest but persistent, and persistence wins in orbital mechanics. They don't create the rings, but they give them edges, texture, and form. Without these quiet sculptors, Saturn's rings would be softer at the margins, less crisp in their lines. With them, the rings become calligraphy bones of ice drawn in strokes, wrapped around a world. Moons also keep records. Some are born with planets from the same spinning cradle of dust and gas, and their chemistry matches the family recipe. Others come from catastrophe. Earth's own moon speaks of a violent collision early in the planet's history, when a Mars-sized body struck and the debris coalesced into a companion that has steadied our axis and stretched our days ever since. Still, others are adoptees from elsewhere, like Triton, around Neptune, or many of Jupiter's irregulars, wanderers caught and kept by gravity. Each case leaves clues: a tilt, a mineral, a density, a scar. Together, moons become a filing system for making worlds. If you want to know how planets grow, collide, migrate, and settle, you read the moons, because the moons never forget. And sometimes they keep more than history. Sometimes they keep oceans. Beneath Europa's ice, there is almost certainly a sea deeper than any on Earth. Enceladus, with its slender geysers, reveals a saltwater reservoir that sprays through cracks near the South Pole and mists the space around Saturn with ice. The jets carry traces of salts and organics, chemical letters of an alphabet life could, in principle, use. At the bottom of those buried oceans, there may be places like the hydrothermal vents on our own seafloor, where water meets rock and heat, and the chemistry turns generous. On Earth, such vents are crowded with life that needs no sunlight at all, feeding on energy and minerals that rise from below. Imagine a field of chimneys under Europa's crust, black water rising, mineral flakes drifting down like slow snow, microbes threading themselves into the flow. Imagine something larger drifting in to graze the microbes. Imagine, not to promise, only to widen the door. The more you imagine, the more the center shifts. We are used to thinking of habitable worlds as planets, Earth-like spheres, warmed by a kind star, perhaps wrapped in blue. But habitability is a formula, not a look. And the formula, water, energy, time, and a workable chemistry, might be met in many ways. Europa and Enceladus check those boxes beneath ice. Titan, with its thick nitrogen sky and hydrocarbon rains, offers a different chemistry entirely. Strange, but not illogical. Ganymede is vast, layered with ice and water, and may hide stacked oceans in a sandwich of liquid and solid deep below the crust. Life, if it exists there, would be slow, patient, adapted to cold and pressure. It would be a page from a different book in the same library. Some moons go further and wear shields. Ganymede, the great moon, generates its own magnetic field. It carries a magnetosphere around itself like a bubble, deflecting charged particles and tracing auroras above its poles. That alone makes it unusual. Planets do that, not moons. But even unmagnetized moons can play with magnetism. Io zips through Jupiter's magnetic embrace and drags electric currents like threads, lighting up the environment with electromagnetic storms. The entire Jovian system is a loom of fields and plasmas, a place where space is not empty but alive with invisible weather. Magnetism gives shape to energy, the way gravity gives shape to motion. And moons can write in both. Even dust matters. Small moons constantly shed tiny grains as micrometeoroids strike and chip them. The fragments drift out and settle into faint rings and halos. Jupiter's inner moon, Amalthea, feeds a gossamer ring, a veil so thin it is best seen at a slant, when light skims the particles instead of piercing them. Saturn wears larger, brighter rings, but it also wears shy ones, dusty ribbons that barely declare themselves except to careful instruments. These halos are signatures of friction and time. a reminder that every surface is in conversation with the space around it. What breaks away does not truly leave. It becomes part of a larger design. Darkness and brightness, clusters and families, metronomes and shepherds, vents and fields, each motif returns with variation. The more you follow these themes, the more the solar system seems less like a collection of things and more like a set of relationships. Consider brightness again. A soot-dark moon hints at a carbon-rich past and a long time without renewal. A bright one speaks of resurfacing, of snow laid down from within. Consider families. A group of small, irregular moons sharing a tilted plane suggests a breakup. A set of large, well-ordered moons in near-circular paths suggests a formation from the same disk. Consider rhythm. Resonance doesn't just keep time, it keeps worlds powered. Consider sculptors. A shepherd moon lacks spectacle, yet it traces beauty that a telescope can see across 1 billion miles. If you widen the circle further, the moons feed back into the planets in quieter ways. Their gravity can stabilize tilts, slow spins, and, over vast ages, quiet a climate. Earth's moon has done all of that. Tidal stresses raised by a moon's pull can nudge Earth's crust when it is already restless, delivering the small push that turns nearly into now. In ring systems, the moons and ring particles trade influence until edges appear and gaps stand clear. There are no idle objects here. Even the smallest bodies pay their dues to the system that holds them. The Galilean moons deserve another glance through that 1,610 lens, if only to feel the shock of that first recognition. Imagine the cold, the awkwardness of the instrument, the blur of Jupiter swelling and smearing as the air above the city trembles. Then 4 companions. By the following nights, they have moved, not randomly, but systematically. There is an order. If there is order there could be order everywhere. And if there is order everywhere, then Earth is not the hinge on which the sky turns, but one weight in a mobile. Galileo wrote down what he saw, and the world read it, and an old certainty let go. The same thing can happen inside a person too. You learn that what seemed to orbit you has its own center, and you let it go, and the sky grows larger. Call back the families and their histories. Jupiter's irregulars whisper of capture. Saturn's shepherds draw filigree. Neptune's retinue bears the scars of strangers folded in. On that far blue world, many satellites trace tilted or even backward orbits, their inclinations like accent marks, telling you they came from somewhere else. Triton, the largest, moves against Neptune's spin, likely the remnant of a captured dwarf planet. Its nitrogen ice acts like wax under the cold, slumping and smoothing landscape into gentle slopes. Voyager once caught geysers of nitrogen insurgent, enough to leave dark streaks on the plains. Even at the damped edge of sunlight, change continues. This is the merciful truth of the outer system. Nothing is truly idle. Enceladus breathes through its tiger stripes, thin fractures near the pole that exhale ocean into space. Prometheus and Pandora tend their narrow track like gardeners. Tiny Pan wears a ring of dust around its middle and clears its lane with a steadiness that borders on ritual. Amalthea sheds faint motes that collect into a faint ring. Himalaya and its kin make darkness part of the aesthetic, proof that not all beauty is reflective. When the mind grows tired of imagery, the body still knows what this means. It means there are cycles that take years, and others that take millions of years. And those long cycles still matter. It means time can be a sculptor and a solvent, It means energy must go somewhere, and somewhere may be down through water to a vent where the chemistry warms enough to become elaborate. It means that life, if it exists elsewhere, might prefer the quiet places, under ice, in the dark, where seasons are measured not by light, but by flecks and whisper. Try to picture that darkness without making it empty. Picture the slow snowfall of mineral grains around a hydrothermal chimney under Europa's crust. Picture the soft glow of ionized gases at Ganymede's poles, where a small magnetosphere rubs against a colossal one. Picture the edge of Saturn's rings fluttering when a shepherd brushes past, a restless pattern that moves like wind through tall grass, except there is no wind, only gravity and countless impacts whispering their syllables. Picture Amalthea's dust at a grazing angle, turned from invisible to delicate glow by nothing but the geometry of light. There is comfort in the idea that the faint can add up to the beautiful. The brightest moon in the night sky reflects only a modest fraction of what it receives, and yet that's enough to guide a traveler or silver a sea. The quietest moon still moves dust and draws lines in rings. The smallest moon helps a giant keep its adornment. Gentle forces, patiently applied, can sculpt anything given time, a resonance that keeps three worlds breathing. A sliver of gravity that braids a ring, a set of geysers that wraps a planet in a scarf. This is why the search for life on moons feels less like a quest for novelty and more like a return to something old. Water remembering how to flow under pressure. Chemistry remembering how to arrange itself when warmth is steady. A system remembering that balance can hold even when nothing is simple. If we find life somewhere like Europa or Enceladus, it won't diminish Earth. It will confirm a pattern that the universe repeats itself in structure, not in detail, and that the ingredients for complexity are common currency. After all this, it becomes easier to fall asleep with the sky in mind. You can let the dark moon slip past like unlit ships, feel the bright ones like frost on glass, hear the cadence of 1, 2, 4, counting itself across centuries, watch tiny shepherds comb glitter into paths, and imagine vents blooming under ice like slow galaxies of heat. You can believe that dust keeps promises in the form of invisible rings, that magnetism can be a kind of weather, that families can form after breakage, and that seeing 4 small lights 400 years ago wasn't an endpoint but a beginning. The moons do not argue, they demonstrate. They do not rush, they persist. They keep to their steps and share their energy and accept their fates. Whether that means wearing a coat of snow-white ice or carrying the black mat of carbon, whether it means tending rings or falling into them, whether it means storing oceans or letting them breathe into space. And when you close your eyes, they keep moving, slowly enough to settle your thoughts, but steadily enough to reassure you that motion is the rule and stillness the illusion. In that knowledge, the night becomes generous. Because not every moon glows, and not every moon must. Some will remain dim, the better to show how little light it takes to be seen. Some will continue to blaze, the better to remind us that renewal is a form of quiet courage. Some will sing in resonance without ever making a sound, the better to prove that rhythm can be real even when silence is complete. Some will stitch rings to edges and dust to halos, the better to demonstrate that small gestures, repeated, become architecture. Together they make a lullaby out of mechanics and history and invite you to rest while the cosmos keeps time. Even air has edges. Around certain moons, You can watch a sky thin and unspool until it is no sky at all, only a faint veil wandering off into space. The lightest molecules slip first, then heavier ones, teased apart by sunlight and flung outward by motion and heat. Io exudes a breath of sulfur and oxygen that never quite settles, its volcanic exhalations swelling into a ghostly cloud that trails behind it like a scarf. Enceladus sighs water, vapor, and ice, a fragile plume that drifts into the dark and lingers as a torus of mist along its path. Triton, far out in Neptune's pale country, launches nitrogen geysers so fine they look like smoke, building a thin haze that leaks away grain by grain. Even Titan, wrapped in a thick orange coat, slowly loses threads from its hem as ultraviolet light worries at the molecules and the wind of charged particles pulls them free. Nothing holds forever. Atmospheres are habits, not laws, and habit can be broken by heat, by speed, by a gravity too gentle to call anything back. Whether a moon keeps its breath or loses it comes down to the simplest arithmetic in the sky: how hard it can pull and how hot its air becomes. A deep gravity well is an anchor, a cool temperature, a calm sea. Shallow wells and warm air make for restlessness. On small, sunlit worlds, the quick molecules run for the edges, and the edges give way. Some of that lost gas folds into a planetary magnetosphere, caught and spun into ribbons of charged particles. Some finds its way into rings, especially where the moon that leaks is also a moon that sheds ice. And some drifts into nothing, a soft, constant leaving written in numbers too small to feel and timescales too large to ignore. The miracle is not that atmospheres escape, it is that any of them stay, travel outward, and the dark grows kinder. Beyond Neptune, the Kuiper belt keeps its own frigid households, dwarf planets and the companions that attend them. Pluto and its 5 familiars, Haumea, quick spinning and elongated, with 2 small moons looping along. Eris, weighty and distant, trailed by Dysnomia. Perhaps there are more out there moons too dim for our present eyes, tucked so close to their primaries they hide in their glow, or drifting so far that a camera's noise swallows them. Each new discovery in that cold is not only a name on a list, but a lever for understanding. A satellite's orbit lets us weigh the world it circles. The world's shape and spin hint at collisions and reshaping long ago. You can think of those systems as miniature versions of the familiar ones, inward, but the analogy runs both ways. The big systems are also magnified copies of the small. The physics doesn't care about scale. It repeats itself with a patience that feels like mercy. It is tempting to imagine the outer reaches as empty, but emptiness is a story we tell when we are tired. The truth is busier. Moons gather around giants like sparks in the air around a wool coat on a dry night. We know a few hundred in our own system and suspect many more. Around other stars, our instruments are just beginning to catch the signatures of exomoons. Faint delays, small dimmings, hints more than holdings. Even if they evade us for a while, the logic is plain. Where there are planets, there are gently bound things and loosely bound things, and many of the loosely bound become moons. Count long enough and the tally could favor the satellites. Planets might be the headlines. Moons are the text. Some keep their distance. A handful of Jupiter's irregular companions swing on orbits so elongated and tilted, they seem almost disloyal, returning late, lingering far beyond the neat procession of inner satellites. Neptune hosts similar outliers, survivors of captures and close calls, their paths written in the handwriting of chaos. Those distant moons can be nudged away in a complicated century. stolen by a passing giant, or left to drift in darkness with no allegiance but the Sunday. The bond is real but tenuous, bound and nearly free at once, like a balloon on too long a string. Others live close enough to hear their planet breathe. Phobos hurries through the Martian sky in a handful of hours, rising twice, sometimes thrice in a day, a gray pebble on a short leash. Io, pressed and kneaded by Jupiter and its resonant siblings, warms from the inside until the heat must leave as lava, as plume, as relentless rebuilding. Some of Saturn's inner moons skim so near the rings that they wear a dusted waistline, a subtle, equatorial swell of gathered grains. Up close, gravity is loud. It stretches crust, tides, oceans, warps orbits, and if the music is too intense for too long, it can pull a moon apart into a ring or press a ring back into a moon. In that realm, you see how small bodies compose large beauty. Pan keeps its lane in the A-ring, a little almond-shaped world with a ridge at its equator like a stitched seam, clearing a narrow groove as it goes. Daphnis, tiny and keen, plows ripples along a gap's edge. Prometheus and Pandora tug at the delicate F-ring, teasing it into threads and braids. Larger moons too, Mimas, Enceladus, Tethys, send out their gravity and emboss the rings with patterns, spiral density waves that look like the grooves on an old record, bending light with structure. Without the keepers, Saturn would still wear a crown, but it would be a soft halo instead of lace. With them, the rings become calligraphy. The planet turns and the letters move, but the style stays legible. Names, even those etched in ice, are a form of gravity. Around Uranus, they come from plays and poems rather than pantheons. Titania and Oberon drifting through a midsummer, Ariel and Miranda, curious and fierce, Umbriel, quiet as a shadow. A few take their titles from Pope. It is as if a library went traveling, characters unmoored from paper and set into an orbiting cast. Astronomy has often borrowed from myth. Uranus borrows from theater, and something about that feels right. Science gathers, stories arrange. Between the two, a system acquires personality. Return to the chemistry of beginnings. Titan's sky is thick and amber, with complex organics, a smoggy cloak woven by sunlight striking nitrogen and methane, breaking them and recombining what's left into bigger molecules that drift and settle. That haze hides a surface sculpted by methane rain and river and sea, where shores are drawn in hydrocarbons instead of water, and dunes crawl like great dark creatures across plains. In its orange gloom, you can imagine an echo of an earlier Earth, a time before oxygen, when the air might have carried a similar haze and the oceans rehearsed reactions that would one day assemble into cells. Titan may not be living, but it is instructive, an archive of chemistry that shows what can be done with time and energy when starlight is filtered and slowed. Elsewhere, the chemistry practices in the dark. Under Europa's ice, the pressure is steady, the temperature not warm but not killing, the water salty and restless. Down where sea meets rock, hydrothermal vents could leak heat and minerals in a slow, sustaining rain. On Earth, such vents drive whole ecosystems that owe nothing to the sun, their energy drawn from redox reactions at the boundary between ocean and stone. Enceladus gives us peaks, salts and organic fragments in the sprayed water, tiny grains of silica formed in hot rock-water interactions, hints of methane that could be geochemical or less likely, but not impossible biological. To picture those environments is not to promise anything. It is to widen the corridor through which possibility can walk. Even moons that leak give back to the systems that hold them. Io's sputtering fills a torus around Jupiter, with sulfur and oxygen ions that the planet's magnetic field whips into auroral storms. Enceladus's lost water seeds Saturn's E-ring, a broad, thin halo glowing in the right light. Triton's escaped nitrogen becomes part of Neptune's scant atmosphere and magnetospheric stew. Titan's slowly shed molecules add faint signatures to a region already rich in subtlety. The flows are tiny but continuous, and continuity alters landscapes in ways catastrophe cannot. Not every change is invisible. In the Kuiper Belt, you can still read the scars of violence in shape and spin. Haumea, stretched and fast, wears its collision in its geometry. Its two small moons sweeping the consequences into circles. Eris, massive for its size and remote, holds dysnomia in a steady loop. Pluto and Charon keep each other's faces, two worlds in mutual lock, while three smaller satellites, Styx, Nix, Kerberos, Hydra, tumble farther out with spins, not much interested in tidiness. Those arrangements let us weigh the primaries and test ideas about how ice behaves when hit hard. Frozen rock behaving like very slow putty over aeons. The further out you go, the older the lessons feel. But old lessons are usually the most useful. If you count, you will run out of fingers, but not of moons. A few hundred here. In the galaxy, likely thousands upon thousands more. Most will be small, most will be quiet, and many will tell you more about the worlds they circle than those worlds can tell you about themselves. A satellite's orbit fixes a mass. A mass constrains a composition. A composition suggests a history. A history gives you a way to guess at a future. Sometimes there is so much future you can feel it resisting the present. Phobos, inching inward, already shows the stress lines of what it will become. Deimos, unhurried and high, will ease outward in time. Between those fates sits Mars, reading both in the same sky. Step back and let the patterns settle. Leakage at the edges, families at the margins, resonances that keep time, shepherds that stitch, names that humanize, chemistry that remembers, dust that draws halos, counts that overflow. The system is not a cabinet of curiosities, but a choreography. Energy moves from light to molecule, from tide to heat, from volcano to cloud, from plume to ring, from ring to gap, from gap to wave, from wave to gleam. Gravity keeps the beat and magnetism colors the sound. Even silence participates. A cratered plane that has not changed in 4 billion years is a statement, not a pause. When the mind begins to wander, let it wander along an orbit. Imagine a tiny moon far from its planet, leaning around the darkness on a path so long it forgets its own beginning. Imagine another braiding the ring edge with each pass, the crisp line of ice sharpening and relaxing like breath. Imagine a haze that sheds itself molecule by molecule and yet never vanishes, because the source is patient. Imagine a library of characters circling a green-blue world tilted on its side, their names whispering Shakespeare into the vacuum. Imagine a sea under ice, under stars, and the thought that heat can travel without light, that life might write itself in cursive we have not yet learned to read. Even air has edges, and yet the story does not end where the air lets go. It extends into the spaces between worlds, into the tenuous halos and reluctant atmospheres. into the faint currents of magnetism that shiver where fields meet. It extends into the company kept by dwarf planets, into the long arithmetic of capture and collision, into the fact that small companions outnumber the large and refine their lives. It extends into the extremes of orbit, almost free, almost falling, and the art those extremes make in rings and cracks and waves. It extends into language, where we lend names that hold meanings we need, and into chemistry, where we remember that the recipe for life is simple to write and difficult to cook, and that some kitchens are colder than we expect, and some stoves are not stoves at all, but tides pressed into stone. If there is a moral, it is not a grand one. It is that nothing is wasted. Leaked gas becomes weather for a magnetosphere, frost for a ring, a trace in a spectrum. A tiny moon arranges 1 billion particles with a finger's tug. A slow resonance keeps an ocean from freezing and a volcano from sleeping. A dim point at the edge of sight anchors a calculation that weighs a world. A name reaches from a stage into an orbit. A molecule broken by light becomes material for a haze that turns a sky into a lantern. And tonight, while you rest, those processes continue at their own paces, fast as a ripple in a ring, slow as a moon leaving its air behind, constant as a resonance, counting 1, 2, 4 across an age. Far from here, where the sun is a colder coin, small companions circle, leak, gather, carve, and endure. They do not require witness to keep their time. They keep it anyway, and in their keeping, they make the dark articulate. Some places in the sky do not promise spring, but they promise shelter. As our species leans outward, the first safe roofs might not be planets at all, but moons, stepping stones of ice and rock, arranged like quiet inns along a very long road. Our own moon is the closest inn, unromantic in its harshness, and yet generously stocked where it matters. In the deep polar shadows, water ice waits. With light and patience, ice becomes drink and air. With electricity, it becomes propellant, the promise of departure, folded into the promise of return. Farther on, Mars offers 2 small lanterns. Phobos and Deimos are not places to unfurl gardens, but they make excellent porches, low-gravity platforms from which to lower supplies to the red deserts, outposts where machines can rest and human crews can catch their breath between sky and soil. Across the cold, Saturn's Titan carries a different kind of welcome. A thick orange sky that softens radiation the way fog softens city lamps. Its air presses gently compared to Earth's, but it is a blanket all the same, a protective hush around a world that rains methane and cradles seas of liquid hydrocarbons. And out by Jupiter, Ganymede brings an improbable gift, a magnetic field of its own, small but real, a personal umbrella beneath the storm of Jupiter's radiation. None of these places are easy. All of them are patient. In time, the map of human travel may be dotted more with moons than with planets. The way early charts of Earth were strung with islands, each one a place to fix a mast or mend a net before crossing the next stretch of dark. Before we dreamed of living there, one moon was already working for us. Earth's companion has kept a long watch, catching some of what falls, diverting a little more, and recording everything it could not stop on the old stone pages of its face. Those craters are not decorations. They are tallies. Not every bullet is intercepted, not every hazard blunted, but the presence of a nearby large target changes the arithmetic of chance. More important still, the moon steadies Earth's posture. A planet's tilt is a delicate thing, the balance between dance partners that can stumble if nudged too often. Without the moon's steadying hand, our axis might wander through wild angles, trading temperate seasons for eras of ice and desert, and back again, too abruptly for much to adapt. With the moon, the leaning stays within patient bounds. Leaf and reef, glacier and river, species and story. So much of what persisted did so because the climate's tempo slowed enough for life to keep time. Sometimes the moon puts on ceremony to remind us of that bond. During a total lunar eclipse, it should vanish Earth squarely between it and the sun, the source of light blocked. But the moon does not go dark. It blushes. The color comes from us. Sunlight passing through Earth's atmosphere is filtered, blue scattered away, red refracted into the shadow like wine into water. For a while, our companion wears every sunset and every sunrise on Earth at once. In ancient camps and cities, this change in color must have looked like anger or omen. In modern backyards, it looks like physics made visible. The same trick that paints evening clouds now stretched across a world. The ceremony is brief. The lesson a planet's breath can color its partner lingers. Systems of worlds do not sit still for ceremony. Planets migrate. They trade places slowly. A million-year shuffle that redraws maps as deftly as it unmoors them. When giants move, they rework their families. Some moons keep up, others are offered to the dark. A few are swallowed, and some are caught. Strangers folded into a new household. Triton, circling Neptune backward, is the quiet telling of such a capture, likely a dwarf planet in its own right, before gravity persuaded it into a different fate. Its presence hints at moons that did not survive the rearrangement. Its retrograde path is a footnote left by a heavy editor. The lesson is humbling. What looks inevitable is often the current state of a long negotiation. Sometimes, new companions are made rather than caught. Imagine a ring, countless particles of ice and dust circling a planet in layered bands, a broad river of glitter seen from far away as satin. In portions of that river, particles can begin to clump. Gravity does what gravity does. A fleck becomes a crumb becomes a pebble grows a neighborhood. Given time, a small body spins itself smooth and, with enough neighbors agreeing on its path, becomes a moonlet, then a moon. Around Saturn, there is growing evidence that some of its small satellites were stitched this way from the ring's bright thread. If Earth's moon is a child of collision, Saturn's little ones are children of adornment, proof that beauty can be an engine for making. Other gifts come from farther afield. Comets move through the planetary spaces like refrigerated couriers, bearing water and organic molecules that predate most of the surfaces they cross. When a comet strikes an airless moon, the delivery is violent, but the receipt can be long. Without weather to wash the slate, without plate tectonics to shuffle the deck, a moon keeps what it is given. Impact craters can trap ancient volatiles. Fractured terrains can hide molecules that matter for chemistry. On Europa or Ganymede, cometary packages may have helped stock the pantry for the experiments happening in concealed seas. Earth once received such deliveries as well, but our planet's appetite for erasing its own history is tremendous. The moons, dry and unhurried, become time capsules, careful archivists of an era when the sky was busier. The archives are not silent. When Apollo crews placed seismometers on the moon, the instruments listened and learned that lunar stone sings differently from ours. A quake triggered by the pull of Earth, by temperature changes at sunrise, or by an impact does not die quickly there. The crust is dry and rigid, Vibrations ricochet through it and linger. The phrase rings like a bell is more metaphor than measurement, but the feeling it evokes is right. Strike the lunar ground and the energy will pace the corridors for a long time before leaving. That ringing told scientists how the moon is built about layers that don't flow easily, about fractures that never healed. For the rest of us, it added a shade of personality to a familiar disk, a world that hums when touched. Head back to Titan, and the personality changes again. Under that thick, amber sky is an entire weather system that looks familiar until you read the labels. The lakes and seas are not water, but methane and ethane so cold they sit like steel blue glass. Kraken Mare sprawls like a small ocean. Ligeia and Punga lie near like sister basins. Methane evaporates, floats as haze, condenses into clouds, and falls as rain silver threads in a dim light gathering into rivers that carve long, branching valleys into water-ice bedrock hardened by cold into something stronger than granite. Dunes of dark organic sand march across plains. Here is a hydrological cycle rewritten in a different ink, the same sentence with new nouns, proof that nature loves patterns more than ingredients. On Enceladus, the cycle becomes a fountain. Near the South Pole, the ice skin splits into parallel fissures, tiger stripes, and heat from within, coaxed by the strain of tidal flexing, keeps those cracks alive. Through them, the moon exhales. Water vapor, snow-fine ice, traces of salts and organic fragments. The spray arcs into blackness and, catching light, glitters before falling back as frost or drifting away to feed Saturn's E-ring, the thinnest scarf a planet ever wore. The stripes run warm compared to their frigid surroundings. They are both wound and window. If you want to sample Enceladus's ocean, there is no need to dig. Fly through the breath, and you will taste what the sea is cooking. Farther out and in another sense, deeper in Europa holds a water story that dwarfs our own. Beneath miles of ice lies a single ocean more voluminous than all the seas of Earth combined. The evidence stacks gently but convincingly. A surface so young and smooth that something must be erasing craters. Long reddish lines where ice has stretched and split, and perhaps let brine touch the airless cold. Magnetic and gravitational signatures consistent with a salty layer in motion. Every so often, a spacecraft glimpses a plume-shaped mystery that might be water flung upward and then lost to space. We cannot yet see the ocean directly, but we can see how the ceiling behaves. It is moving. It is listening to tides. It is pressed from below by a sea that refuses to freeze solid because its world refuses to stop flexing. Between these grand features and the humbler ones lies a web of effects that makes systems into systems. When a moon leaks a little gas, the magnetosphere catches it and paints auroras, or the ring system grows a faint new ribbon, or a planet's upper atmosphere finds a new trace to carry. When moons pull on rings, rings answer with waves. When rings shed crumbs, moonlets collect them. When planets migrate, orbits are shuffled, and old arrangements are lost, but new ones are found, sometimes more stable than what came before. The slow processes are the trustworthy ones. They have all the time they need. Return, now, to the question of refuge, and ask it more carefully. On the moon, long nights fall like a curtain, half a month of darkness, half a month of harsh light. The cold cracks metal, the dust clings and scratches, the vacuum forgives no error. And yet, under those extremes, ice waits in permanent shadow, and a base can be planned around what is constant. Shadow for storage, light for power, regolith for protection. At Mars, Phobos and Deimos offer logistics rather than comfort. Places to park fuel, assemble landers, and keep fragile bodies away from deep gravity wells. On Titan, the atmosphere is both gift and challenge, thick enough to make parachutes grateful, cold enough to make breathers cautious. On Ganymede, a field that could be described as small and planet-like in the same sentence would still mean we must build habitats as if under siege from Jupiter's radiation. None of this is discouragement. It is design guidance. We have lived in deserts and on rafts. We have lived in winter. We have learned to carry our climate with us. The moons ask only that we do it with better math and longer patience. Stand again in the red hush of an eclipse and notice how the moon's color tells a story about a different world's air. Then remember that the reverse happens all the time. Worlds tell stories about each other by the way they move and what they shed. Triton tells of a capture. A cluster of irregulars around Jupiter tells of distant origins. A tiny shepherd tells of a ring's architecture. A resonance tells of heat inside stone. A plume tells of an ocean's chemistry without ever showing you the sea. Even the stubborn ringing of the moon after a small shock tells of dryness and fracture, of a place where energy takes its time to leave. The comets, too, keep weaving through all of this. A strike on Europa might leave more than a crater. It might deliver a patch of organics that, over time, percolate downward into brine and become food for a chemistry that does not need sun. Impacts on Ganymede's bright and dark terrains could salt the boundary layers between ice and water with carbon compounds robust enough to survive cold and pressure. The record of deliveries is not a clean ledger, many entries smudged by later events, some erased by geothermal editing. But airless moons keep better books than Earth does, and careful reading can recover a surprising amount. In a single human lifetime, the list of places we suspect could host life, or something like the preface to life, has grown from one to several. Titan, with its lakes and chemistry rich in carbon, models atmospheres that might have set the stage for biology here. Europa and Enceladus, with water, energy, and salts, model interiors where biology might not need a star at all. Even Ganymede's nested oceans, if present in the layered way some models suggest, hint at a complexity of habitats stacked like rooms in a house whose windows are sealed but whose floors are warm. The odds are not promises. They are invitations. It is possible to see the moons as a progression, from refuge rocks, to ringmakers, to ocean keepers, to theater troops around Uranus, and miss that they are also one thing, evidence that the universe favors relationship. A moon is defined by the body it circles, but it also redefines that body in return. The moon steadies Earth's tilt. Io fills Jupiter's magnetosphere with sulfur. Enceladus gives Saturn a ring. Titan pulls methane into weather and performs, under a haze, a shadow play of lakes and storms that makes us rethink habitable. None of these actions are grand in the moment. They are grand in the aggregate, in the way a heartbeat is grand only after you've counted 1 billion of them. Meanwhile, inside us, the same drift toward patience can take hold. You can imagine a habitat tucked against a crater wall, doors facing a sun that rises slowly, a set of hydroponic trays gleaming green under artificial day, while outside the regolith holds heat like a bank. You can imagine a small observatory on Phobos, Mars rolling beneath like a slow drum, the sky changing faster than the ground. You can imagine a boat on Kraken Mare, heavy, sealed, careful, listening to rain strike a methane sea the way rain strikes any sea, and feeling the continuity of pattern across an abyss of difference. You can imagine a quiet flyby through the breath of Enceladus, instruments sipping the mist for salts, for molecules with the ring of familiarity, for proof that an ocean has been talking to stone in the language life prefers. You can imagine, from high above Europa, watching a pin-thin line of red-brown trace of fault across unblemished white, and knowing that below that line, water is restless. In the end, the catalogue of what moons do shield, steady, blush, migrate, form from rings, store comet gifts, ring with quakes, rain methane, breathe ocean, hide oceans reads less like a list and more like a biography of motion turned into meaning. Their stories braid into ours without asking permission. That, perhaps, is why the idea of living on them feels less like conquest and more like a chord. We are not needed there, but we might belong there if we can learn to move slowly enough to keep to rhythms already established, to borrow shelter without breaking the walls. Some nights, when the air is clear and the moon is full, you can feel the bargain. It steadies our seasons and lengthens our days. We answer with careful attention and an occasional set of instruments left near a flag. The rest, the red eclipses, the far captures, the ring-born children, the ocean breaths goes on whether we watch or not. And that is a comfort. Because while we build the next roof at the foot of a crater, or across a Martian sky bridge, or under an amber cloud, the moons will keep doing what they do, serving as small, reliable promises in a vast, changing night. Not every orbit is forever. Some moons are being quietly reeled home, the way a loose thread winds back into the spool. Phobos is the exemplar small, gray, and dutifully circling Mars, while the planet's tides ever so gently draw it inward. The pull is soft, but patient pulls are the strongest kind. Give it tens of millions of years, and Phobos will either be torn into a ragged ring or fall into a final embrace with the red deserts it has watched for ages. Other moons, depending on their size and distance, feel similar tugs. The physics is not cruel. It is simply persistent, reminding us that even the sturdiest companions are written in eras rather than eternities. Orbits evolve, futures end. Some endings are quiet. Some will draw luminous arcs across a planet's sky. Not every moon was born where it lives, either. Many of the faint, lopsided satellites circling the giant planets move on tilted, elongated, even backward paths. They advertise their foreignness without a word. The likely story is capture. Icy migrants from the solar system's far edge, perhaps members of the Kuiper Belt's ancient population, swept inward by slow dynamics and complicated encounters, then caught and kept by a planet's gravity. Triton, bright and cold around Neptune, is the archetype. A large body on a retrograde orbit, almost certainly a former dwarf planet that traded the freedom of heliocentric travel for a place in Neptune's family. Captured moons are time capsules with accents. Their orbits carry fingerprints of distance and cold. Their surfaces keep the chemistry of a frontier where sunlight is a rumor and time is a craftsman. The spectrum of size among moons is its own astonishment. At one end are the almost not moons, knobby, potato-shaped bodies, only a few kilometers across, spinning and tumbling like pebbles tossed into the dark. Deimos is a gentle example, about 12 kilometers wide, a soft, dim star drifting high above Mars, more rock than world. Jupiter and Saturn keep whole cabinets of such objects, each one a small fossil that never got swallowed or shattered during the great construction of planets. They lack the gravity to pull themselves round, so they remain odd, faceted, storied, unpolished relics of the solar system's early workshop. At the other end are moons with planetary ambitions. Ganymede is larger than Mercury. Titan wears an atmosphere more substantial than Earth's. Callisto, old as stone prayer, and Io, frantic with volcanoes, both outmass our own moon. If these giants orbited the sun directly, we would call them planets without hesitation. Instead, they circle larger worlds, yet carry their own deep histories, internal oceans and iron cores, weather and chemistry, magnetism and heat. They blur the nomenclature on purpose. The universe is not obliged to honor our labels. Extremes are not only a matter of size. The coldest places measured in our solar system are not on the farthest worlds, but in craters near the moon's poles, pits of permanent night so deep that sunlight never touches their floors. There, temperatures fall to a stillness colder than Pluto's noons, cold enough that water molecules landing in the dark may lie untroubled for billions of years. These are vaults, not landscapes, freezers that keep their contents long after the recipe is forgotten. Someday, explorers could chip ice from those shadowed holes and turn it into air and drink and fuel, the way sailors once hollowed snow from mountain crevices and boiled it into tea. In contrast, elsewhere, a moon can be so bright with clean ice that it manufactures its own shadows. Enceladus, resurfaced by geysers and glassed with frost so fresh it squeaks, reflects almost everything the sun gives it. Against the black, it beams like an obedient mirror. Its brightness is not vanity, it's biography, a sign that the surface is renewed, that plumes keep painting the ground with new snow. Between the deepest cold and the sharpest shine, there is a quieter extremity, stillness. On the moon, where air is absent and weather never arrives, footprints last. The crisp treads pressed by human boots, the looping tracks of rovers, the tripod scars from landers, even flags stiffened by rods rather than breezes. These marks persist because nothing there conspires to erase them. No rain, no wind, no stream, no creeping lichen. Time sifts dust over everything, but only very slowly, so a moment becomes an exhibit, a gesture becomes a geology. What on earth is ephemeral turns on the moon into a patient archive we visited. The surface remembers. Creation has not stopped, though. At the ragged edges of Saturn's rings, you can watch infants being knit. Icy particles, crowded and nudged by tides and shepherd moons, begin to gather into clumps. Gravity turns clumps into aggregates, aggregates into moonlets. From a distance, the process looks like embroidery, a border thickening along the rim of glitter. Small stitches pulled into shape by a steady hand. Given enough time and enough inbound ice, such moonlets may grow, step outward, and earn decades-long names of their own. The nursery's right there, visible in reflected light. Not mythology, but mechanics. Not legend, but slow arithmetic. Elsewhere, the arithmetic runs backward. Bodies collide and certain moons shatter, yet gravity is conservative, reluctant to waste. The pieces dance and re-encounter, settle and reattach, until a single object emerges, often stranger than before. Pan, the little flying saucer moon within Saturn's A-ring, may wear the shape of such a reassembly. A central lump with a collected equatorial ridge, ravioli rather than sphere. At planet scale, we suspect our own moon was born from a more violent version of the same principle. A collision with a Mars-sized body tore Earth's mantle into orbit, where it forged a companion, that would later steady our planet's tilt and stretch our days. Destroyed and created are poor words for processes whose boundaries blur. In gravitational systems, there is mostly rearrangement. We do not yet understand every arrangement. Some origin stories are clear enough: impacts, captures, coalescence from a disk or ring. Others remain unsettled, even after decades of data. Triton's capture seems likely. The details of how energy was shed and previous moons displaced or lost are still debated. Many irregular satellites could be fragments of larger bodies, broken in ancient collisions. Even the classic giant impact tale for Earth's moon is now elaborated with variants and refinements. Multiple impacts, different initial spins and temperatures, mixing and fractionation that make the chemistry so eerily similar to Earth's own rocks. This is not failure, it is progress. Each mission adds footnotes. Each footnote refines the chapter. The suspense is not theatrical, it is scientific, patient, and real. Meanwhile, the catalogue of moons beyond our neighborhood sits in pencil. Candidates for exomoons flicker through data as timing shifts and faint dips. The signatures are fragile, the telescope's busy, the confirmations hard. Theorists, impatient in the best way, sketch out what might be there. Earth-sized moons, orbiting close-in giant planets, bathed in warm light. Super Titans, with thick skies and slow weather. Ocean-bearing moons tidally heated enough to keep water liquid far from their star. Some could host life. Some could host chemistry practicing for life. Many will simply be beautiful in ways we haven't learned to imagine yet. When the first certain exomoon is announced, it will feel less like a surprise and more like a door finally willing to open. Return to the spirals, the slow descents and slow ascents. Not every moon moves inward. Some drift outward as tides trade a planet's spin for a satellite's distance. Our own moon is gradually leaving us, 1.5 inches each year, lengthening our days by imperceptible heartbeats. Others, like Phobos, come home. The difference depends on the balance of masses, on the friction of tides, on geometry and timing details that seem petty until you realize they decide whether a moon survives as a friend, becomes a ring, or vanishes into a world's atmosphere like a final rumor of motion. In astronomy, destinies are often just averages, integrated over unreasonable amounts of time. Even the tiniest satellites matter to the shapes that surround them. Shepherd moons, some so small they could nap in a county, sculpt Saturn's rings with grace that defies their size. Daphnis raises scallops and waves along a gap's edge. Pandora and Prometheus tug the delicate F-ring into braids and streamers. Pan keeps a lane clean by absorbing and repelling particles as it circuits its groove. The result is a living score. Density waves like grooves on a phonograph. Eccentric ripples that march outward at set speeds. Sharp edges that hold their lines the way a practiced dancer holds a pose. Without the shepherds, the rings would still glow. With them, they speak. Captured moons speak too. They tell us that the solar system has always been social and occasionally unruly. Their odd angles testify to gravitational three-body problems solved in real time over eons. Their surfaces carry the unhurried varnish of deep cold. Their families cluster in groups that suggest breakups and captures layered like sedimentary rock. When a captured moon is large as Triton is, the capture can refashion an entire satellite system. What was there before is jostled, some pieces thrown out, others consumed. When the capture is small, the effect is gentler, a new accent in the outer court. If extremes in origin and orbit draw the mind outward, extremes in temperature and light pull it inward to the senses. It is strange to think the coldest measured places are practically next door, inside pits you could point to with a fingertip on a lunar globe. It is equally strange that a little moon can cast a shadow crisp enough to carve itself into a photograph taken from far away, not because it is bright with fire, but because it is very, very good at catching light and giving it back. Albedo reflectivity is a physical quantity and a metaphor. A high albedo says, "I have been repainted, snow laid down by plumes and frosts." A low one says, "I am old, darkened by radiation and dust." Both are true statements, and neither is moral. They are just the ways surfaces keep time. The moon's surface keeps time in another way, too. Human artifacts lie where they were left, unruffled by weather, the color bleached, but the geometry intact. Future visitors could walk the same routes, stepping carefully to honor the archaeology of exploration. In a world that changes quickly and forgets easily, it is sobering to know that there is a place where a footprint made half a century ago looks as if it were pressed this morning. This is not sentimentality. It is a reminder that our stories, like a moon's stories, are partly a matter of environment. Some histories need storms to stay alive. Some need the absence of storms to remain legible. Where new moons are knitting themselves from rings, others are knitting themselves from memory. Shattered bodies reassemble. Fractured surfaces anneal under cold pressure. Rubble piles settle into conditional unity. The universe is not gentle, but it is economical, and gravity is the most frugal force we know. It wastes nothing, it can reuse. Likewise, the ring nurseries that manufacture moonlets may also be memorials to older moons torn apart when they ventured within a planet's Roche limit. The line between birth and recycling is a ring itself, and like rings, it is beautiful precisely because it is complicated. Even mystery is not a failure of knowledge, but a space for it. Why does this irregular satellite group share such a specific tilt and distance? How exactly was Triton's enormous orbital energy dissipated by tides alone, by an atmospheric phase, by interactions with a pre-existing satellite family now gone? How many impacts, and under what thermal conditions, would reproduce the chemistry we measure in lunar rocks and terrestrial mantle alike? There are instruments en route to sharpen some of these questions, and others will be designed after we see what the next flyby reveals. Curiosity is a tide of its own. It flexes the interior of culture, heats it, and keeps it from freezing. And beyond all this, the rumor of exomoons thickens. Somewhere around a star we do not yet know by name, a giant planet may be ferrying a retinue of small worlds close enough to their sun to glow in soft daylight, each with weather and irregular terrains. Elsewhere, a large rocky moon might orbit a gas giant in the habitable zone, its day side flushing with subtle auroras as it moves through its planet's magnetic field, its night side cooling beneath a sky laced with the planet's rings seen edge-on like a disciplined cloud. Perhaps there are moons with methane cycles more extravagant than Titan's, or moons with oceans deeper and saltier than Europa's, or moons whose surfaces are mostly organic frost that crunches underfoot like black snow. We will need better eyes to see them. Better eyes are coming. If there is a theme binding these last strands together, it is impermanence made beautiful by pattern. Moons spiral inward and outward. Some are adopted, some abandoned. A few are pebbles. A few could sit in the planet gallery and not look out of place. The coldest shadows shelter ancient ice, while the brightest mirrors reveal young skin. Footprints stay. Moonlets take shape even as other moons are ground to rings. Violence breaks. gravity remakes. Origins are argued, futures are open. And above the speculation of exomoons, there is the steady implication that whatever we find will both match and surprise the logic we have learned here. Listen to the cadence hidden in all this. Pull and release, capture and escape, shatter and gather, dark and shine, memory and making. It is the same cadence that has carried the story from the first glance at four lights near Jupiter to the present web of questions and plans. It is not a march, it's a tide. And in that tide, moons are not ornaments. They are verbs, spiraling, shepherding, freezing, reflecting, storing, ringing, forming, reforming, constantly turning motion into meaning. So the story circles back to silence. We began with moons as distant lights, pale beads stitched across the black, and followed them through orbits, collisions, and rebirths. Now, as the last of them drifts through your thoughts, the pattern becomes clear. Nothing in the universe truly stands still. Every moon, every world, even every breath is part of the same long rhythm of movement and change. Out there, Phobos inches closer to Mars, while our own moon drifts farther from Earth. Some moons are being born inside Saturn's rings, others are being unmade, scattered into dust. In this endless exchange, the solar system feels less like a machine and more like a living tide, everything pulling on everything else, shaping and reshaping across time. And yet, for all this motion, there is peace in it. The slow spirals, the faint reflections, the silent footprints on airless ground, they remind us that impermanence is not loss, it is participation. Every moon carries that truth. To exist is to move, to change, to shine for a while, and then give your light back to the dark. So let the thought settle softly. Picture those drifting worlds continuing their patient circuits long after you fall asleep. Tiny mirrors, frozen seas, dust and fire, all humming in a cosmic rhythm that never stops. Breathe with it. Feel the pull of their orbits, matching the rise and fall of your chest. And as you drift, imagine yourself among them floating, turning, quiet, one more traveler carried gently through the dark.